Hello. This recording is on week three's research paper. The title of my research paper was Earthquakes and Their Influence on the Construction Industry. In week two, we had the opportunity to discuss earthquakes, and Professor had mentioned he was surprised that nobody had brought up the correlation between the construction industry and the earthquakes. So I thought I'd delve into it a little farther. So, like I say, we briefly glossed over the basics of earthquakes and how they were formed and what they are and why they are so prevalent in our region. This presentation is informative regarding the influence of earthquakes and their influence on the construction industry as a whole. There's a special attention is being placed on the safety of our public buildings and our hospitals. So depending on the proximity of your relationship to an active fault line, there are varying degrees of force that a seismic event would affect in the structures in that region. So a seismic zone could be one of three things: a region on the map in which a common level of seismic design is required, an area of seismicity is assumed for the purpose of calculating probabilistic ground motions, and there's another one is a region of a map which a common areal rate of seismicity is assumed. So up until 1969, the building code maps usually used a numbering system for the different zones, where 0 would be the lowest level of effect by a seismic event, and some of the numbering systems would go as high as 6. 6 being the most severely impacted by a seismic event. Over the years, the seismic events have become studied by contractors and engineers who sought to find better ways and methods of constructing buildings that would react and survive or have a better survival rate in seismic events. Different jurisdictions have different building codes, and as a rule, all of them have agreed upon the necessity of acceptable building methods that focus on seismic events and the location. Southern California has its own little climate. In San Diego County, we have different fault zones that affect our high-rise buildings as opposed to, say, Los Angeles, and then as far up as San Francisco. All of us those three regions are still affected by the San Andreas fault, but there are several sub-faults that we're individually affected by. The governing codes by which everybody has to adhere are varying. Everybody pretty much has to conform to the Uniform Building Code, or the UBC. There's another code that architects, engineers, and builders have to adhere to, and that's called the IBC, or the International Building Code. Then, of course, since the Uniform Building Code and the International Building Code, well, California has to be special and have their own as well. So they have some more stringent or some different, more centered codes that address things that are only particular to California. Then there's the ASCE, the American Society of Civil Engineers. Of course, there's the Unified Facilities Criteria, and everybody's favorite, the FEMA Building Code, the Federal Emergency Management Agency. If you've ever had to deal with them, it's quite the bureaucracy. The thing about different regions and their stringent rules, San Diego's a little more lax than Los Angeles and San Francisco. Well, Los Angeles has their own set of building codes, and they require certain things for adherence to their building codes, just like New York City does. There's a lot of buildings in San Diego County that I've had the pleasure of working in. I'm in construction. So I've worked at Kaiser Hospital on Zion Avenue, and the very beginning, that building was quite old. And over the years, they've upgraded the seismic recommendations or codes that affect that building. So we would have to go back in and do a retrofit of all the piping or the supports to ensure that they kept up with the new codes. Hospitals are very stringent on that. With all these different codes to adhere to, there became the need for structural engineers to actually specifically address and work in that field of seismic events. There are companies that we in the mechanical industry and mechanical electricians and plumbers, MEP coordinators, they all use pretty much the same companies that do this seismic supports and stuff. The companies that I've dealt with most often is called ISAT, or International Seismic Application Technologies, and Mason Industries. I'm sure there's a lot of others out there, other businesses that do the same stuff. I've just had the most firsthand knowledge of working with these two. These two companies, as well as some of the others, retain their own engineers that have gone to school and got their engineering degrees that are specialized in dealing with seismic activity or earthquakes and how to keep things in place, and the pipings and the hangars and the equipment associated with the buildings. In regions where earthquakes are prevalent, it's not enough anymore just to pour a big old chunk of concrete, throw some rebar in it, and start building on it and hope that it doesn't come apart. These engineers and architects have to take into consideration the total complete structure, from the concrete and the foundation itself to the iron structure, and then everything that goes on the outside of it, the inside of it, the final furnishings, and the people that are supposed to be in it. So they need to incorporate and understand what the weights of all that will be, as well as the final occupancy of the building. Then if that isn't enough, they also have to take into account and just acknowledge the effects of the region itself. And that's where California is different than, say, Nevada or Arizona. They need to, excuse me, take into consideration the weather patterns, and whether it's all rainy or earthquakes, typhoons, whatever that region is, they have to address those concerns as well. Besides just the regular office buildings, I was trying to explain that there's a different set of codes or a different level of adherence to building codes in, say, an office building or just a manufacturing warehouse than, say, a hospital. Hospitals have their own oversight inspectors that are way more stringent than, say, your regular building inspector. The OSHPD inspectors are, well, let's define OSHPD first. OSHPD stands for the Office of Statewide Health Planning and Development. So the health planning development should be a real eye-opener and a dinger that says, hey, wait a minute, this this has to do with life safety services. So the insurance that the building is still going to stay standing even in the event of an earthquake or a catastrophe of sorts is their main responsibility. They need to ensure that their job is to observe and report. They need to observe that the building has been designed properly with all the right attention paid to the structures and pipe sizes and electrical voltages and structural members. But then they check on the actual plans themselves, make sure that they're accordingly done properly. Then they'll take a look at the submittals and whatever the architect and the engineers have agreed upon for the individual products being used to build the building, are that the contractors are actually installing the correct product in the correct application. Not all nails are the same quality nails, same with screws, same with concrete. There's so many different levels and mixtures of concrete that if the engineer is banking on, he's made all his calculations and his design on one special mix of concrete, and then the contractor says, well, I can get it a lot cheaper if I use this other mix, but that mix isn't as strong or doesn't have the same characteristics. So that's where the OSHPD engineer and the OSHPD inspectors keep the contractor in line and on the same page with the architects and engineers. Hospitals are so concerned about their ability to provide adequate care, regardless of the catastrophe, that occasionally they'll actually do mock training scenarios where they take a building and they'll kill the power and run off of their emergency generators for a period of time. They'll also mock out if they had a plumbing emergency. There's all kinds of scenarios that they train for so that there's no surprises, or at least the people know how to react in the case of an emergency. Some of the hospitals are termed as trauma centers, and these require even a bit more stringent requirements, not only in the inspection of the building and the products, but the building needs to be able to not only withstand the seismic event or the catastrophic event, but it also needs to be able to function completely for 72 hours, disconnected from any power, water, sewer, anything like that. They need to be self-sufficient. I had the privilege of working on one such building in La Jolla at the Scripps Hospital, the new, what's his name? The Conrad Priebus addition to the Scripps Hospital in La Jolla. The mechanical room there has, underneath the mechanical room, they have these big holding tanks, one's for fresh water and one's for sewer. And they have big diesel generators that generate the power. At the moment that the power turns off, say a big line goes down from here to Arizona and takes out all the power of Southern California within like just a few seconds, if that, the main generators turn on and take over the load, and it's called a UPS switch. It's uninterrupted power switch, and essentially that's what it does. It detects that there's a problem in the power being supplied, and it automatically kicks on the generators and takes over until the outside power is regained or stable again. Then it will kick back off. So they practice these things on a regular basis. In the 32 years that I've worked in the construction industry, I've found that working on OSHPD jobs is significantly more difficult than most any other construction jobs. And it's for good reason, because all of our lives could be at stake at any time. So, as you can see, earthquakes really have had an influence on the construction industry for the better. Just as the tech world has new developments, so has the seismic or the construction industry in regards to seismic protection. They'll come up with a new product that does a whole lot more work, which is either stronger, better, safer, and especially in a zone or an area where earthquakes are prevalent, these are things that need to be taken into account. Anyhow, this is my presentation for week 3's research paper, and I hope you have a great day. God bless. Talk to you later.